All right, in this video we are going to introduce you to MongoDB. MongoDB is a document-oriented database, so this is quite different from traditional SQL databases where everything is laid out in tables. Mongo is going to lay its data out in what's known as documents. Now the documents are actually stored as BSON, which is binary JSON. So as you work with the database, you'll get things coming out of the database in a JSON format. So you'll be working with a lot of JSON when you're dealing with Mongo. But this is significantly different than the relational model that you may be used to. Now the word Mongo is derived from humongous, and I know I mispronounced that. I'm not very good at that word, but that is where Mongo comes from. It was developed all in C++. And like I said before, it is a no SQL database, so significantly different than working with traditional SQL databases. MongoDB was developed in 2007 by a company called Tengen. In 2013, Tengen changed their name to MongoDB, Inc. So they originally developed Mongo as a PaaS application, so platform as a service. And then they took it to open source in 2009, and I think they found a lot more success with that business model. A little bit of history about Mongo. Some of the early adopters were SourceForge, Foursquare, and I'm not even sure if Foursquare is still around. They were quite popular at one point, but in the U.S. they seem to have fallen off the face of the earth. I'm not sure if they're still in business, to be honest. Craigslist and eBay. And today Mongo is used by a lot of large companies, including MetLife, Facebook, Expedia, and Google. And looking at my metrics from springframework.guru, I've got several posts on MongoDB, and those are very popular. And my YouTube channel, I also have some stuff about MongoDB up there and Spring Boot, and that's one of my top videos. So it is something that's gained a lot of popularity in the marketplace, and I see it out there more and more. Now, why would you want to use MongoDB? It's great for high insert systems, like sensor reading, social media systems, or like advertising systems where you're doing a lot of insert type activity. And also a lot of read activity too. Mongo, you can cluster Mongo servers and distribute their load and create replica servers. So it's very, very scalable. So you can definitely scale up with Mongo quite inexpensively because it will run on minimal hardware, and you can do a lot of instances that will replicate to each other. And it's also nice when you need schema flexibility. So having your data in documents and in a JSON format, it gives you a lot of flexibility to add properties as your requirements change. Now, there's some pitfalls with Mongo. Some people avoid Mongo. It really has no concept of transactions like we saw with traditional relational databases. So we talked about ACID when we talked about MySQL. And that's one of the things that makes Mongo so much faster, is because it's not dealing with all the protections of the ACID transaction. So in MySQL, there's a lot of locking that's happening to make sure that you're not stomping on each other from other sessions or other threads. In Mongo, you don't have that protection. So you can get lost updates inside of Mongo. If you have the risk of updates on the same record, not a good use case for Mongo. And if you watch Josh Long doing presentations, he does like to joke about MongoDB losing data. So I would use Mongo for a lot of things where, like, think about Facebook, where someone is liking a post. If you lose a like, so what? Really, at the end of the day, so what if that like gets lost? But if you're doing a bank, not a good use case. If you're dealing with dollars and cents, probably not a good use case where you have weird errors happen with dollar terms. Now, some terminology as we move forward with Mongo compared to traditional relational databases. Both of them are called a database. Inside of a traditional relational database, you have tables, but Mongo calls those collections. A relational database will have rows within the table, where Mongo will have documents inside the collection. Properties are called columns inside database row, where in a document they'll be referred to as fields. Now, one of the powerful features of a relational database is being able to do table joins. You can do something similar with Mongo, and they call that embedded documents. So you get a reference to the document embedded inside another document. Both of them have primary key, and then aggregation is a little bit different. And this is where you're like going and doing a sum operation. So just a terminology difference there, really, but the approaches are fairly similar. My experience with Mongo has been pleasant. It is takes a little getting used to working with it directly. From a Spring perspective, when we're using Spring Data, as you'll see, it is fairly transparent. Spring Data, Mongo does make it very easy for us to work with the Mongo database, and it does have some unique capabilities. A lot of it is going to be in terms of the flexibility of the database schema, where we can add properties without having to manipulate it. So like in a relational database, you have to go and add a column to a table if you want to use that. In Mongo, you don't have any schema to manipulate. You just add that property and start using it. So your database migrations become much simpler, as you'll see going forward in this class. So we're going to have a lot of fun with Mongo. It does support streaming out of the database and non-blocking streaming, more importantly. So we will be using that in the future as we get into reactive programming and non-blocking programming. That's why we're bringing Mongo in the course. But what we're going to do first is convert over our recipe application, because I want you guys to see how easy it is to use Spring Data. And we're going to go from Spring Data JPA to Spring Data Mongo, and we'll have some minor code changes, and we're going to look at that in the next video.